Hello, in this video I will going to talk about solving quadratic trig function. First exercise is solve exactly on 0 to 2 pi. If possible, there's going to be a trick question. Now, first is cosine squared theta plus 3 cosine theta minus 1 equals to 0. Again, I'm familiar with cosines. I can just write it as x. I have x squared plus 3x minus 1 equals to 0. Well, you can use AC method to factor it. Let's see if that works. AC method says that I want two things multiply equals to -1, and I want two numbers when they add equal to 3. Well, I couldn't think of any number will work because multiply you only get 1 and -1 when they add is equal to 3. Nope. So if it doesn't work, well, we can use the quadratic formula, which is x equals to -b plus or minus b squared minus 4ac over 2a, where in this specific case a is equal to 1, b equals to 3, c equals to -1. So x is equal to -b plus or minus b squared minus 4ac. Oh no, I made a mistake. So c should be a -1, not just 1. You need to include a negative sign, so here would be a -1 over 2 times 1. So our solution would be -3 plus or minus square root of 13 over 2. So that means our cosine theta is going to have a two solution. Is either cosine theta equals to -3 plus square root of 13 over 2, or cosine theta equals to -3 minus square root of 13 over 2. Okay, let's say which one would work. So our theta, how do I find it? This is not the special triangle that we deal with, because we deal with the square root of 1, 2, 3. Remember that? 1 over 2, square root of 2 over 2, and square root of 3 over 3, or either 1 or 0. But this is too complicated. But remember that we learned something before is the arc, the inverse function. So that means right now, I want the inverse function I want to solve this inverse function and this inverse function. There's two ways to write it. Okay, I know that we can solve it, so we need to use a decimal to help us to solve the solution. Okay, decimals, we have arc, cosine, -3 at square root of 13 over 2. This is equal to what? 1.263, and the second one is arc. Same thing, except for we're changing this to become a negative. Okay. Oh, not arc, cosine. Oh, this is undefined. Why is that? Do you know what caused the undefined? Okay, I'm going to write down the solution first. So first is this guy is impossible or undefined. or doesn't exist. And this one, the first one, is equal to 1.2632 radians. This is not in degree. If you want to convert this to degree, that means you need to use 1.2632 radians times 118 degree over pi, or 318 degree over 2 pi, either way. So you can convert this to degree. Or you can go ahead and do it in decimals. After this, you just multiply 118 divided by pi. So the degree would be 72 degree. You can just round the final answer into the whole number. I'm fine with that. Okay, so now let's talk about why this is impossible. That is because we know that for a cosine function, if you look at a cosine function, the graph of a cosine function look like this guy, right? The maximum would be what? 1. The minimum would be -1. If you are above that, beyond these 2 points, that would be impossible. It would be undefined. So now, take a look at this function. This is going to be greater than a -1. How do I know that? Because let's do some algebra in here. For algebra, I have -3 minus -13. So this is almost like a negative square root of 9 minus -13 over 2. So when does this is -1? If cosine theta is equal to -1, so that means this is going to be a -2 over a 2, right? Which is negative square root of 4 over 2. So this gives you a -1, right? But look, this is already negative square root of 9 minus square root of 13. That's a much bigger than -4. So that makes this whole value is significant less than -4. So that means this is going to be smaller. That means below -1. Okay, let's move to the next question. Oh, we're not done. Sorry, we're not done in here. So I know that our theta, this is the reference angle. We found the value of the reference angle. The reference angle, theta, is equal to 72 degree. And then I know that cosine theta is -3 plus square root of 13 over 2, which is a positive number. So that means for cosine, if it's a positive number, this is going to be in the first and the fourth quadrant. Okay, how do I know that this is positive? Because you have a -3 at square root of 13. So -3 basically is -9, negative square root of 9, and then plus square root of 13. So I know that square root of 9 is a small number, and square root of 13 is a bigger number. When you have a smaller number adding to a bigger number, this is going to be a positive. That's why I know that this whole thing is going to be a positive number. Let me change the color of that. Okay, now get back to here. So I know that theta, reference angle, is 72 degree, and it's going to be in first and the fourth quadrant because cosine is positive. So that means my unit circle would be in here. First answer, 72 degree, right? So that means our solution, first solution will be 72 degree. The second one, the reference angle, also 72 degree. So that means our theta is equal to 360 degree minus 72 degree, because this is going to be our second theta, the second solution, which is 218.8 degree. That's it. That's the two solutions. So let me recap this question. So to do this question, the first thing I do is replace the cosine to become x, so that I have a quadratic function x squared plus 3x minus 1 equals to 0. And then I use quadratic formula to solve for x. Well, after I solve for x, this is not the regular measurement that we are familiar with. So that's why I use a decimal to help me to find the solution. So the decimal give me two answers. No, the quadratic function give me two answers, and then I found out that one of these answer is undefined on decimal, on the cosine. Why is that? Because it's below the -1, which is already outside the range of cosine theta. So that means we only have this solution. With this solution, I solve that this is 72 degrees, which is a reference angle for the cosine theta. With the 72 degree, I found the reference angle, and also since this is a positive number, so I know that cosine theta is positive if only if they're in first and the fourth quadrant. So that means I have two solutions. One is in the first quadrant, the other is in the fourth quadrant, and then I solve the two angle. Okay, so that's the whole way to solve it. Now I'm going to give you another examples so we can practice more. Now 2 sine squared theta minus 5 sine theta at 3 equals to 0. First thing, I would write it to x or y or ABC. 2a squared minus 5a plus 3 equals to 0. We can use AC method or quadratic function. I'm going to use AC method. So AC method says that I want two numbers multiplied together equals to a times c. So let me have that. When they multiply equals to a times c, which is 2 times 3 is 6. And then when they add is equals to b, which is -5. So what would be that two number? It will be -2 and -3. So that means I have a 2a squared minus 2a minus 3a plus 3. Now we group it. First group, second group. The first group I got factor out the common factor 2a. I have a minus 1. Second group, common factor would be, I can factor the -3 out, so I have a minus 1 equals to 0. Then here, common factor a minus 1, so I have a minus 1, so the rest would be 2a minus 3 equals to 0. Now, I solve a is equal to 1 or a equals to 3 over 2. Okay, so let's rewrite a into sine. So I know that sine theta is equal to 1 or sine theta equals to 3 over half. Again, this one, sine theta is already beyond its range. That means it's above 1. So that means this is going to be impossible. It's undefined. There's no way we can find sine theta such that they will equal to 3 over 2, which is 1.5. And now sine theta equals 1. Well, sine theta equals to 1 should be an easy one, because sine in here is equal to 1. So that means this is going to be our angle, which theta is equals to pi over 2. That's it, because we want all the solution to be in 0 to 2 pi. Everything is in this domain. All right, solution. Oh, let me circle it. Okay, last example. C. 3 cosine square x minus 2 cosine x equals to 2. Now, let's rewrite the function in the way that we are more familiar with. Since there's already x, I'm going to use y. So I have 3y squared minus 2y minus 2 on both sides. So that gives me a 0. Again, this one, AC method doesn't work. That means I need to use a quadratic formula to solve our problem, where a is equal to 3, b is equal to -2, c is equal to -2. So quadratic formula, I have negative b plus or minus b squared minus 4 times a times c over 3 times a, which is 3 times 2. Oh, maybe the 2a, sorry. So I have a 2 plus or minus 4 plus 13/6. No, did I do something wrong? 4ac. Oh, this is 2. I wrote this wrong, but I self-correct very soon. And then I have a 4 plus 24. Over 6. Simplify. I have a 2 plus or minus square root of 28 over 6. Square root of 28, we can factor the 4 out, so we can write it as square root of 4 times square root of 7. So I will have this guy. Simplify it. They are both divided by 2, so my answer would be 1 plus or minus square root of 7 over 3. Now, that's the value for y, so that means our cosine x is either equals to, oh, why this doesn't work, 1 plus square root of 7 over 3, or cosine x equals to 1 minus square root of 7 over 3. One of these. And again, we need to use a decimal to help us to solve the solution. So I have arc, the inverse function, 1 plus square root of 7 over 3, or the inverse function. So there's 2 ways to write down the inverse function. Okay, let's check our answer on decimals. So I have arc, cosine (1 minus square root of 7 divided by 3). Well, this is equal to 2.151 radians. So that means we need to multiply 360 degree over pi, which is equals 246 degree. Oh, sorry, it's divided by 2 pi, not pi. So it's 123 degree for the first solution. I'm going to write this down, 123 squared. Just use the whole number. Don't worry about the decimals rounding. Okay, the second one is when this guy here become add. Well, it's undefined. So that means it's maybe beyond 1. It's above 1. So that means it's undefined. So now we have 2 answers. The first one gives us 123 degree. The second one is undefined. All right. Remember that. Okay, let's see where's 123 degree. 123 degree is in the second quadrant. This, it will be 123 degree. So 123 degree will help us to find the reference angle. So the reference angle, let's say theta prime is equal to 118 degree minus 123 degree. That would be 57 degree. So that helps us to find the 117 degree. But that's not done. They help us to find the reference angle. The actual reference angle is 57 degree. And now cosine x, because this one doesn't work, I'm going to cross that. Cosine x, this is a positive number because everything is positive. There's no way it's negative. If its cosine is positive, so that means we expected our answer is going to be either in the first or the fourth quadrant. So that means, oh, sorry, I copied this down. This should be undefined. The undefined one is here. This guy is equals to 123. I write this wrong. I know something is off. Okay, this one is undefined because it's beyond 1. But this on the other side is equals to 123 degree, 123 degree. And now let's take a look. Because this is already in the fourth quadrant, I know something is off. Anyway, so this is going to be a negative number. How do I know that? Because square root of 1 minus square root of 7, this is going to be a negative. If the numerator is negative, that means the denominator will be a negative. Okay, we found the first angle correct. It's a negative, and the reference angle still 57 degree. All right, so that means cosine is going to be in the second and the third quadrant. Now, the third quadrant will be here. The reference angle is 57 degree. So that means another measurement for this is going to be 180 plus 57 degree, which is 237 degree. So our solution will be 237 degree and 123 degree. That's it for this answer. Again, you see that I made mistake. Usually it's come from when I copy down the answer, I'm careless. But sooner I already noticed that something is off because I know that if this is positive, meaning that it will be in the first and the fourth quadrant, which is no way because we already found the 123 degree. That is the first one that we found. And this is in the second quadrant, right? So that means I did something wrong. So it's more likely that I copy the wrong answer. The actual should be this guy is 123 degree. Anyway, just be careful when you're working problem like that. I'll see you in the next video.